This is the DarkWynter WickedFly game entitled EleMental the Recurrence, and as you might guess, is designed to teach students recursive algorithms. After taking a pretest to determine the skill level of the student, we have them play the game and administer a post-test. The whole process takes about an hour. The first thing that you see when you get into the game world are instructions telling you to right-click to release the mouse from the world and allows you to open the compiler and instruction forms. The instruction form asks you to write Hello World, a simplistic C# program that we use to introduce the students to C#, which is slightly different than C++ or Java, and to the game interface itself. Once the students have successfully written and compiled their code, a bridge extends from the island that they are on to the next island, allowing the students to actually step into the game world. We have the students walk a binary search tree in a depth-first search pattern, which is a recursive algorithm. The students go down to node B, as you can see here, and then to D, and then to H. If you can see all the way down to H right now, there's a little purple guy standing down there, kind of bouncing up and down. That's our health, and as you collect them, you'll notice in the top left-hand corner, your health will go up. This is to motivate the student's traversal through the tree. Moving along, it takes a while to traverse the entire level. We come to level 2. In this level, the students finish a halfway completed depth-first search algorithm. Unlike the first level, students are actually coding the movement of the little AI character inside the game itself. As you can see, we allow them to make the code window full screen for ease of use. We then ask them to change the left side of the depth-first search algorithm. I programmed the game, so I'm going to cheat a little bit and copy and paste the code. I changed the node return right to return left if the value is not null, and then I actually do a depth-first search on the tree. Finally, I compile and run my code. Everything runs successfully, and I watch as the AI traverses the tree in depth-first search pattern. This gives the students more of a global view of the code instead of the previous local view. I'm skipping through some of the video to save time, but you can see the AI finishing up the depth-first search right now. Now we're going to the third level as soon as the AI is done. In the third level, we have removed more of the code, asking the students to code both the right and left side of the search algorithm. After reading the instructions, I'm going to go ahead and make this full screen. I am then going to work first on the right-hand side, replacing the insert your code with my own code. The if statement that I'm working on right now will check to see if the right node is null. If it is not null, it calls the depth-first search algorithm. Now I'm going to, once I'm done with that, I'm going to tell the AI to walk the nodes in the depth-first search pattern. Now, if the student runs and compiles their code at this point, you will see that there is an error message that will pop up on the HUD and also in the compiler output window. This is the exact error message that they would receive if they were using Notepad and a console or a standard IDE such as Visual Studios. It allows them to actually get a feeling of why their code doesn't work, and also grounds it more in reality for them. This is what they would be seeing if they were using a normal IDE. Now I'm going to code the left side of the tree. Again, I wrote the game so I get to copy and paste the code, but we don't necessarily tell the students that they're allowed to copy and paste in the game. They have coded the program and there are no compilation errors, but they have not coded the program the way that we want them to. We will then pop a customized error message on the screen. As you can see, I have returned right instead of left, so I get a custom error message. I need to change that to return left. Once my code passes the compiler after I make my changes, and then all of our checks, it will build a bridge down to the first node, just like in the first level. However, if you look on the right side of the screen, you will see two boxes with depth-first search and the node name once we get down to B. As you get down to the D node, we'll add another little blue box on top of the stack. When you get to H, we will add another one onto the stack and then remove it once you have collected the little L standing down there for your health. Recursive algorithms work as a stack, so this is a good visual for the students. You will notice we do not pop off D once we get back up there. That is because we have to go down to I, collect the I on the stack, pop it off, and then return to D before we can pop the D off. The stack metaphor helps the student relate the local view to the global view. We will then go back up to the D, and it will pop off the stack, as you can see in just a second. Once the students finish this level, they take their post test. And hopefully prove that they've learned something while playing our game. So that is our game. Thank you very much for watching. I hope you all enjoyed. Thank you.